Hello students, we will see merge sort and quick sort here. Let's see merge sort first. Merge sort is an external sorting algorithm. It follows divide and conquer method. Divides the input array into two equal halves and then merges the two sorted lists. It is useful for sorting linked lists. Let's see this example 23, 15, 29, 11 and 1. First it divides the given array of elements into two equal halves. Then again it further divide the array. After dividing it perform the swapping operation and finally it merges the elements. The best case, worst case and average case of merge sort is order of n log n. It's a stable sort and not in place sort. Similarly, let's see about quick sort. Quick sort is also called as position exchange sort. It also follows divide and conquer method. Here it picks an element as pivot and partitions the given array. Pivot element picking is very important and it can be either random or rightmost element, or it can be leftmost element, center element or highest value in an array. After choosing, all values less than pivot will be in one side and the greater will be on the another side. And another point is not needed to be split into equal half. This quick sort is not a stable sort but in place sort. When comparing quick sort and merge sort, quick sort works well for smaller array but merge sort can be of any size. Similarly, quick sort requires minimum space and merge sort needs more space. Let's see a bigger example for merge sort and quick sort. The given values are 13, 30, 25, 8, 32, 17, 40, 43. Now we need to divide the given array of elements into two halves. Okay, so the first four coming here and the next four elements are here. Again, divide them into array of size 2, 2, 2. Okay, divide everything. Again, you need to divide further. So 1, 1, 1, 1. Now let's compare and combine them. So let's get started. 13, 30, no change. Then these two, 25, 8, yes, you need to interchange. Similarly, 32, 17, yes, change them. 40, 43, no need. Again, 38, interchange. 30, 25, interchange. 13, 8, you need to interchange. So, in these four elements, it is being in sorted order. Similarly, here also 17, 32, 40, 43, no need to move further. It's already in sorted thing. So, it's over. So, now what we need to do? We need to do merging. Merging together. So, together sorting and merging, we will be getting the final value. That is 8, 13, 17, 25, 30, 32, 40 and 43. This will be the example for merge sort. Now let's see an example for quick sort. Let's take this example 10, 16, 7, 12, 15, 6, 3, 9, 1 and a bigger element infinity. And here we have choose 10 as a pivot element. We need to perform the partitioning algorithm concept. Okay. So let's start I and j values. I will be in this first position and j will be in that first position. Okay. In reverse order. What we need to do is increment I until you find the number greater than 10 because 10 is pivot. And similarly, decrement j until you find a smaller element than 10. This is the concept. So you have to perform doing this. Okay, let's start. So I is here and j is here. Now see, 16 is greater than 10. So you need to increment. So I is pointing here and j is less than this value. This 1 is less than this. So you need to decrement. So j is here and I is here. So I is here, j is here. What you need to do? Exchange those values. So 16 and 1. Okay. So after exchanging, I have written here in this red pen 10, 1, 7, 12, 15, 6, 3, 9, 18, infinity. Okay. So 1 and 16, its position gets changed. Now what we need to do? We have to again continue this. Increment i's position is here. So increment I until you find a greater number than 10. This is not. So the I position will be in this position. Okay. And decrement j until you find a smaller number than 10. So it's smaller. So j will be here and I will be here. Okay. This is I position and this is j's position. Okay. What you need to do? Exchange 12 and 9. So 12 and 9 is being changed. So what will be the elements now? 10, 1, 7, 9, 15, 6, 3, 12, 16, infinity. Okay, now what we need to do? You need to start incrementing here and decrementing there. Increment I. So I is here, coming here, and decrement j. So j is here. Now what we need to do? You have to interchange 15 and 3. Okay. 15 and 3 is getting exchanged. Then continue. Now I is here, j is here. You need to start the process again. I is coming here and seeing, but it is not greater than 10. So I is going here and j is decrementing here. So i's position will be this thing 15 and j is getting decremented to 6. So when I and j swaps each other, stop there. Okay, there you have found the position for pixel that is pivot element. Okay, so the pivot element area we have found out. So you have to exchange j element with the pivot. So j value will be going here and 10, that is 10 will be coming here in the place of j. Okay. So after that we have fixed 10 and before 10 this pivot, everything will be less than 10. And after this element, every value will be greater than the pivot. Again, you need to perform the same partitioning procedure for this element and for this element, and finally we will be getting the answer. Okay, this is the principle behind quicksort. Hope you have understood merge sort and quicksort in this lecture. Thank you.